Okay, class, in the video that I showed you earlier, you learned how to find the slope of a line. Well, in this video, I'm going to show you some applications to do with slopes. One of them is horizontal lines. A horizontal line is a line that has no slope. So if you plug in the y2, y1, x2, and x1 into the slope equation, your answer should end up being 0. So for my example, we have this line right here. And it certainly looks to be horizontal. It don't look like it has any slope. But we need to test this by using the slope formula. y2 minus y1 divided by x2 minus x1. So in this particular example, y2 is 3, as you can see, and y1 is y2 is 2, as you can see, and so is y1. So on the top, you should have 2 minus 2. The bottom, x2 minus x1, we'll say x2 equals 3 and x1 equals negative 2. So plug this into the equation and you have 3 minus negative 2. And this simplifies to 0 divided by 5, which equals 0. And since the slope is 0, that means that this line is horizontal. So another application with slope is vertical lines. A vertical line is one that goes straight up and down, and whenever you try to calculate the slope of a vertical line, you will come up with something that is undefined. I'll show you what I mean by that. So for this particular example, y2 is equal to 4 and y1 is equal to negative 2, as you can see. Also in this example, x2 and x1 both equal 1. So on the bottom we have 1 minus 1. This simplifies to 6 divided by 0. But no number can be divided by 0. So this means that this equation is undefined. So the slope is undefined. And that proves that this line is vertical, because when a slope is undefined, that means that the line's vertical. So this line is indeed vertical. Alright, so two more applications to with slope is parallel and perpendicular lines. So for my example for parallel lines, I've got this. And parallel lines, as you can probably recall, are lines that go on forever and ever and never touch. Now these lines certainly look parallel, but there's a way we can test this. Alright, so whenever you have parallel lines, the way you test if they're parallel is you find the slope of both lines. And if the slopes are the same, that means the lines are parallel. Alright, so let's go ahead and solve this. First, let's find the slope of the top line. So the slope of the top line, y2 equals 3, and y1 equals negative 3. So we should have, or no, y2 is 3, and y1 is 0. So on the top, we should have 3 minus 0. And now x2 is 0 and x1 is negative 3. So down here we should have 0 minus 3. Or no, my bad. 0 minus negative 3. Because the x2 value is 0 and the x1 value is negative 3. So whenever we simplify this, we have 3 divided by 3, which is equal to 1. Therefore, the slope of the top line is 1. Now we need to find the slope of the bottom line. So on the bottom line, y2 is 2 and y1 is 0. So on the top we have 2 minus 0. Now x2 is 2 and x1 is 0. So on the bottom we also have 2 minus 0. And this simplifies to 2 over 2, which is equal to 1. As you can see, both of these slopes have both of these lines have a slope of 1. Therefore, they are parallel lines. Because when lines have the same slope, that means they are parallel. So these lines could go on and on forever and never touch. So that is an application that you can do with slope. Now the final application for today is perpendicular lines. And perpendicular lines are lines that intersect one another to make 4 90-degree angles. Now these lines look perpendicular, but we need to test that. So the way you can test whether lines are perpendicular is you find the slope of them. And if the slope of the first line times the slope of the second line equals -1, then the lines are perpendicular. So first thing we want to do is let's find the slope of this line right here. So in this line, y2 is 2 and y1 is 0. x2 is -2 and x1 is 2. So this simplifies to 2 divided by -4, which simplifies to 1/2. So this, or -1/2, my bad. So the slope of this line is -1/2. Next, we need to find the slope of this line. So in this line, y2 is equal to 2 and y1 is -2. x2 is also 2 and x1 is 0. So this here simplifies to, let's see, 2 minus -2. This simplifies to 4 over 2, which simplifies to 2. So the slope of this line right here, or this line I mean, the slope of this line is 2. So now we have the two slopes, -1/2 and 2. And the way we test to see whether these lines are perpendicular is we multiply the slopes. So 2 times -1/2 equals. Now, if these lines are perpendicular, then the final answer here will be -1. And 2 times -1/2 is indeed -1. Therefore, these lines are perpendicular. Alright, so that's the final application for slope for today. So let me go ahead and give you your homework. Alright, for homework, I want you to tell, for number 1 and 2, I want you to tell whether the line is horizontal or vertical. So, right here is number 1. And here is number 2. So I want you to work it out the way I showed you and tell whether each line is horizontal or vertical. And I want you to show your work. Alright, so for number 3s and for number 1, for the last two problems, I want you to tell if these lines are parallel or perpendicular. So the first thing I want you to do with these lines is I want you to graph these equations like I showed you a day or two ago. After you graph the equations, you can then proceed to find the slope, and using the slope of the lines, I want you to tell whether they are parallel or perpendicular. So that's all for homework, and so just do that, watch these videos, and come to class tomorrow. We'll go over the homework, and I might teach you a little bit about something else, slope-intercept form. So that's all for today. Bring in your homework completed tomorrow, and I will see you tomorrow.